It's lovely to be here, and thank you in particular to you, Isabel. Okay, so today I'm going to be talking about how we're using digital technologies to identify Dead Sea scribes. We will talk about the method, Maruf and I, only one swap with the headphones. And then at the end, I'm going to, and this is the exciting bit, introduce you to one of our scribes. Okay, so Dead Sea Scroll Scholarship and Scribal Identification. It's an ancient collection of approximately 1,000 scrolls, but in their current state, we work with over 15,000 fragments, so they're disintegrated, most of them. It's common in scholarship for people in our field to say almost every scroll was penned by a different scribe, or over 500 scribes wrote the Qumran manuscripts. The most famous currently identified scribe is the scribe of the Serech HaYahad, or the Rule of the Community scroll. It's one of our big long scrolls, about 8 columns long, and this scribe is also believed to have penned 4 to 6 other manuscripts, as well as, if you know our collection, he wrote interlinear corrections in the Great Isaiah scroll. Approximately 8 other scribes have been identified, said to have written between 2 to 3 of the manuscripts. And then down the bottom, in 2007, a well-known paleographer in our field identified a scribe that she believes wrote 54 and potentially up to 90 of the Qumran manuscripts. So I put this one on bold because one of the central focuses of my work has been to test this claim of our work. She put it forth with minimal explanation and authoritatively. What she was arguing, though, however, is that a great amount of variability can be accounted for in the handwriting of a scribe due to such things as environmental factors, writing implements, and also changes over time. So what I've been trying to work out, though, is how much variability can be accounted for in the handwriting of one scribe. This is the problem. Audience, what do you think? Same scribe or not? People don't like being asked questions, do they? Yadani put these 4 scrolls together, along with these 3, along with about 80 others. What she argued is that the lamed, do you know what a lamed is? It's the letter with the mast, that this is idiosyncratic to the scribe, and she argued it was idiosyncratic to the scribe due to the pressed and curved lower part of the lamed, and that all of the other differences that you can see can be accounted for due to variability in the handwriting of a scribe. A lot of scholars rejected the claim. However, I was quite interested to read recently in an article, Do Confessions Tape Perceptions of Handwriting, that actually experts, be it in facial recognition, DNA analysis, as well as obviously forensic handwriting analysis, what we're actually more likely to do is reject a genuine match than accept a false one. And that's experts from all fields. So we're taking 76 of these manuscripts, about 15 of them were just too small or not clear enough, and we're testing them. We're testing the ones with the so-called idiosyncratic lamed, because it could be technically a style. So some would say, no, that lamed is part of the Herodian round semi-formal style. Okay, so lucky for me, my colleague here, Maruf Dhali, is able to take manuscripts that look like this and turn them into this. We binarize images. Some people have asked us recently, I know most of you understand, but we have been asked recently, why do we still keep binarizing? When I look at this, it's pretty clear. So these manuscripts are old, they're decayed, they're damaged, and there's so much background noise on the image. Due to the cracks, the disintegration, that bottom one, you can't even see the writing. So now we can make it look like that. And then fundamentally, really, in automatic handwriting analysis, all that really is needed is the handwriting. So it is to these images that we apply feature extraction algorithms. We apply two, a textural-based one, namely the hinge feature, and a grapheme-based method using fraglets. Lambert and Maruf were talking about that. The idea of using two is that we can tap into two different perspectives. The hinge taps into the genetic perspective, movement, hand structure, and the grapheme-based methods tap into the mimetic, and that's the style elements. Our feature extraction algorithms, we need them to translate aspects of handwriting into feature vectors. For you computer scientists, in machine learning, feature vectors numerically represent an object's characteristics, and in our work, obviously, the object is the handwriting. And so while there are numerous feature extraction algorithms, we've tested, Lambert talked about testing, early on in our project, and the hinge feature proved the best. You can see that article if you like. And the handwriting characteristic that hinge measures relates to curvature and also the slants of the contours of the letters. The hinge feature is an edge-based directional feature. Computer scientists tell me that the aim with developing these features was to tap into changes in direction undertaken during writing, which I thought was amazing. But how does it do that? How is that possible? So firstly, handwriting is a moving process, and so it's dictated by the rules of physics. So imagine like a car, you're driving a car, and the sharper the bend is an indication of where the deceleration happened. And obviously the sharper the bend, the greater the deceleration. And so therefore, through measuring the curvature in the handwriting, it becomes possible to measure the writing process, and therefore obliquely the individual writing hand. So we have this little joke that we can reach back and shake hands with the scribe. Okay, so that's hinge. Then we've got the character, shapes, and fraglets. I was going to give it to Maruf, but they did talk a little bit about that, and for ease of time, maybe we'll just move on. But we've combined the fraglets with the hinge. Okay, so this is the fun bit, and it's taken us a while to get here due to the binarization and then the testing of the methods and then the combining all of the methods, but I finally have a scribe to introduce my field to and to you guys too. We call him GQS01, so the Groningen Qumran scribe. So we know for certain, well, we can accept almost with certain that one scribe wrote the 5 on the left, and then we also know for certain that the 3 on the right were written by the same scribe. We're still trying to work out, though, whether it's GQS01, GQS02, or whether they're just all together. And then also with those 10 in the middle, it's not quite so clear. They're close, but anyway, I'll show you why it's not quite so clear with this graph. So, can you see the blue? I'm sorry, it's kind of... oh. Okay, the blue. So we have this cluster here, and then we have this cluster here, red, blue and red. So that's the 3 I talked about, and this is the red ones we talked about. They're close, but are they close enough? But then you also have to imagine that this is a 2D representation, 2-dimensional representation of what is actually, a 5,365 dimensional space. So imagine then if we just turned that into a 3D space, you would notice that the relationships that the dots have with each other would move a little bit. The distances would change. And then if you made it a 4D or 5D or 6D or 5,365D space, then the relationships keep changing. And therefore, why it gets a little bit harder to tell with some of the manuscripts. So what we're working on now, and this is where the work is up to, is creating a probability curve. So I'll quickly give over to Maruf to talk about that. Sorry, I've got lots of hair. Okay.
Yeah, hello again. Yeah, we tried not to change much. So I'll just explain this thing. Why I'm coming here is when I was working with classical paleographer like Gemma, they always ask this simple question that give me an answer. Is it a writer or not? So the thing is that for computers, it's really difficult to give you an answer like this, that yeah, this is a writer and this is not. We cannot do that. Even with the feature space, all we can give Gemma is like different distances. Then just giving distances among the feature files doesn't really say anything. So we created a curve like this for Gemma. It's like we can, in general terms, it's a FAR, FRR curve. So one of them is the false acceptance rate, another one is the false reject rate. To understand simply, the green line here you see is we can say the distance OK curve. What does it mean? That on the left side, it is actually the percentage, and on the bottom x-axis is the distance. So the more you increase the distance between the features, the less chance it is that it is the same writer, or it's more chance that you're going to do wrong. And the purple curve is the distance error curve. So the higher the distance goes, the higher the probability is you're going to accept a wrong writer as your same writer. So, and the cross-section point we call the equal error rate, ERR. And now it's kind of like the decision of the classical paleographer like Gemma that how much distance they are going to allow. And what does the distance mean? It's the variability of the writing style. And I think I'll give it back to Gemma, and she will explain more.
No, I think I'll probably end. Yeah, so obviously then the last thing is why do we do all this work? And what does it mean for our field? So once I have the scribe, once we've firmed up the last of the numbers, I'm going to do what I call profiling the scribe. And I'm going to ask questions like, does this scribe have literary concerns? And what would they be? And I'll look at those literary concerns in terms of the categorization systems in our field. We have a categorization system that has sectarian, non-sectarian, biblical, and Aramaic. But what's really exciting about this scribe is we now know that he wrote Aramaic texts, as well as sectarian texts, as well as one text that's categorized as non-sectarian. So what does that mean? And as I said, I've touched on, we'll look at the language and then the themes. So what connects the themes of the Aramaic texts with the themes of the Pesherim texts, which are interpretive texts? And then lastly, I can look at spelling practices. So looking at how the scribe uses orthography and morphology. Does he change his orthography or morphology depending on the text, his writing, and that kind of thing? Because orthography and morphology has been used to say in our field, oh, this scroll was written at Qumran, and all of the other scrolls weren't written at Qumran. So I can look at some of those issues as well. Once I can go on to the micro level of an individual scribe, which has been the major aim for the humanities side of the project, as well as having all the benefits for the computer side of the field. All right, thank you very much.